Hello, good day viewers. In this tutorial today, we are going to solve a problem under relative density. So let's look at the problem. The problem says a piece of stone weighs 80 grams in air, 60 grams when completely in water, and 66 grams in liquid X. What is the relative density? What is the relative density? So the formula that you are going to use here is to find the upthrust in liquid and then upthrust in water. So let's write the data. A piece of stone weighs 80 grams in air. Weight of object in air is 80 grams. 60 grams when completely in water. So weight of the stone in water is equals to 60 grams. And 66 grams in liquid X. Weight of stone in liquid X equals to 66 grams. So now, let us find the upthrust in water and then the upthrust in the liquid. The upthrust in water will be upthrust equals to weight in air minus weight in water. So upthrust in water equals to weight in air 80 grams minus weight in water 60, which will give us 20 grams as the weight of the object. That means the upthrust in water. So let us find the upthrust in liquid. The upthrust in liquid X is equal to weight in air minus weight in the liquid X. So which is equal to weight in air is 80 grams minus weight of stone in liquid X, and the weight of the stone in liquid X is 66 grams. Now if you substitute, you will have 14. So this 14 is the upthrust in the liquid X. So we can write the formula of relative density as relative density equals to upthrust in a liquid X divided by upthrust in water, which we have the value of upthrust in the liquid X as 14 divided by the value of upthrust in water as 20 grams. So now if we divide 14 by this 20, we will have 0.7. Remember, relative density has no unit, so we will have